Complex numbers. All right, so in order to understand complex numbers, the first thing we need to understand is imaginary numbers. And later on in the lesson, you'll understand how imaginary numbers are part of complex numbers. But let's start with the basics. So imaginary number is the square root of a negative number. So for example, the square root of -1 is I. So anytime you have a square root of a negative number, you're going to end up with an I. Okay, so here we go. Imaginary numbers can be written in the form of BI, where B is the real number and I is the imaginary unit. So if we just have the square root of I, we just have I, and we know that there could be a 1 as a coefficient there. But if we're simplifying something like the square root of -2, we can split that up into the square root of 1 times the square root of 2, and then we have I root 2. Okay, so if we have roots, we're always going to write the I first so that we don't think that the I is underneath the square root. Okay, then here if we have the square root of -4, then we would take -1, the square root of -1, times the square root of 4. Since that simplifies to 2, we end up getting 2I. And so we always write them in the form of BI, and then we'd switch it around if it was a radical and we needed to say I root 2. Okay, next, simplifying square roots of negative numbers. So we said that we use I when we're simplifying square roots of negative numbers. So before we might have said we can't do that, it's impossible, so now we're going to use I and we can actually do this. Okay, so the example that we're using here is the square root of -12. So if we're going to do the square root of -12, what we're going to start out with is we're going to factor out a -1. So we can split that into 12 times -1. So we split it up. And then down here, we're going to actually split it into 2 by using the product property. So the product property says it's okay to split those apart. So we split them apart, and then we're going to start simplifying. So we know the square root of 12 can split up to the square root of 4 times the square root of 3, and that can be simplified to 2 root 3. And then we said that the negative square root of I can be separate there, and we know that that turns into I. So we'd have 2 root 3I. And like I said, the I always needs to come out in front of the radical so we don't think that we're taking the square root of I. So it turns into 2I root 3. Remember that the I always has to go in front of the radical. Okay, so we're going to try 2 examples here. Alright, so go ahead and pause the video and see if you can simplify these. Alright, so let's go ahead and simplify them together and see if you did it correctly. So for this, I'm going to go ahead and factor out a -1, and then I can split them up. So I know the 16 simplifies to 4, so I now have 3 times 4. And then I remember that the root of -1 simplifies to I. So 3 times 4 is 12. And I have 12I, and my radicals have gone away. Alright, so let's try to simplify this second one here. So we have this negative symbol outside of here. So we're going to leave that out of there. And then I'm going to split this up into 25 times 3 times -1. Okay, so I've split it into its factors. I'm going to use the product property to write that out. So square root of 25 times the square root of 3 times the square root of -1. So the square root of 25 would be 5, and I have that negative out there. And then the square root of 3 would be square root of 3, and the square root of -1 becomes I. And then remember, I can't leave that at the end there because I don't want it to look like it's a square root of 3. So I'm going to put this in the front, and there's my final answer. Okay, if it helps you to think about this in the beginning as a -1, you can put a -1 out there, and then you'll remember at the end that you're going to multiply that in, so your final answer would be -5I square root 3. Alright. So another way we could use these if we're solving quadratic equations with imaginary solutions. So we haven't talked too much about solving quadratic equations, but you should be able to solve this. So In order to get rid of a square, we know that the opposite is a square root. So I need to go ahead and take the square root of both sides. So if I take the square root of both sides, that's going to cancel that out over here. But on this side, I now have the square root of negative 81. So I know I can split that up into negative 1 and 81. So hopefully we know that the square root of negative 1 turns into I, and the square root of 81 turns into 9. So I have 9I. And since I did not really know starting off, this could be a positive or a negative, and either way, if I square it, I could get negative 81. So my answer is going to actually be positive or negative 9I, because I'm not sure if it's a positive or negative 9I that ends up giving me the negative 81. Okay, moving on over here. So if I solve this, I'm going to use inverse operations. I'm first going to subtract 75. Okay, then I'm going to divide by 3. So I end up with this, and then if I take the square root of both sides, remember when I take a square root, I don't know if it's positive or negative because it's x, so we're not sure which it is. So it would be positive or negative. Okay, the square root of 25 is 5, and then I have that negative 1 in there, so it would be I. So what I could plug into this equation would be positive or negative 5I. And if I plugged in positive or negative 5I, it would give me the solution to my equation. All right, moving on. Okay, so you might want to pause the video for a second here and get all this written down, because this is all really good information, and then I'll go ahead and explain it. Okay, so complex number, a number that can be written in the form of a plus bi. So the a and the b part are going to be real numbers. And remember that real numbers could be irrational, rational, so fractions, decimals, all of those things count. Okay? And then the I part is going to be the imaginary part, which is the square root of negative I. Okay, so before we were talking about real numbers, and we talked about rational and irrational, how they're split into rational and irrational. So real numbers are actually a part of complex numbers. So the other part of complex numbers is imaginary numbers. So complex numbers are all of these combined. You could have real numbers, which again, a real number are a subset of complex numbers, where b equals 0. So therefore you don't have the imaginary part because b equals 0. On the other side, imaginary numbers are part of complex numbers, except for in imaginary numbers, the a part equals 0. And we can't have the b part equaling 0, because if the b part equaled 0, then the whole thing would be 0. So just a equals 0 and b is not equal to 0, and those are the imaginary numbers. However, when you put together a real number and an imaginary number, you get the complex numbers. Okay, but then again, to be clear, all of these are complex numbers. It's just that these have b equals 0, and imaginary numbers have a equals 0, but they all fall into this category of complex numbers. Okay. Lastly, when we talk about I, we need to be able to use the powers of I. So it's important that you memorize this pattern. So here's the summary of it, but I'm going to go through and explain. So in your notes, you need to have this down. But just to kind of go through, of course, the square root of negative 1 is I. So I to the first is just I. When you have I squared, that's a square root of negative 1 squared, and you get I squared, which turns out to be negative 1. Okay, then if you go to negative 1 to the third, that's the same as I to the third. So we could split that up into I squared times I, and we just said that I squared is negative 1. So negative 1 times I is actually negative I. So you can see here, I to the third is always negative I. And lastly, the square root of negative 1 to the fourth would be I to the fourth. If you split that up, it's I squared times I squared. And we said that I squared is always negative 1, so negative 1 times negative 1 is 1. Okay, so I went through all of this so you could see where they came from, but what you really need to do is you need to memorize this pattern, and you need to memorize these first 4, And then during class, we'll talk about how to apply these to other situations.